So yeah, my name's David Cruzy. I think I know a fair amount of you guys. So I'm going to be talking through some of the changes in SMB 302, and feel free to raise your hand with questions as we go, or find me afterwards, or likewise find Greg and Chibo and a couple other people from the dev team might be swinging through here too, or talking to Tom and stuff like that. And if you have any related questions too, at the end we'll have a Q&A section, and at that point, if you want to open it up to anything on SMB 3 or SMB 2, or God forbid SMB 1, we can talk about it all. So in general, we're going to talk through the SMB 302 changes, and then I do want to touch a little bit more about the diagnosability feature, because I actually think you guys are going to find that quite useful, as we do as protocol implementers on either the client or the server side. And I mean, the biggest thing, Tom talked about it some yesterday, I didn't make it, but the biggest thing I want to stress here is that, like, SMB 302 is not like a full-fledged dialect upgrade that everyone has to go. These are small incremental features. Pretty much all of them are optional, and for those of you who are still pursuing an SMB3 solution, there's no need to re-rail to try and address all these things. I think as we go through them in a little bit more detail, what you might find is that either a lot of them don't apply to you, or are things that are relatively minor to do and stuff like that. So, and that sort of gets into one of the big discussions that we had when we were going into sort of our blue release cycle, which is, should we even increment the dialects at all? Because these are, again, minor changes, and we have capability bits that we could actually use to try and denote servers that could do some of this stuff. But in general, while capabilities are useful, what we've done in the past is try to use capabilities as a way for a server to express what optional portions of a protocol spec that they actually implement. But the idea of introducing capabilities after dialects have already shipped just seems like a sort of an odd solution, because now we're sort of introducing behaviors where someone who negotiates the SMB3 dialect could start seeing capabilities that weren't defined when the SMB3 dialect was actually introduced, and the risk of either issues or odd behaviors or security bugs or something starts to go up. And for those of you who've been around it on SMB1 and you know cap NT RPCs and cap remote API, like this idea that you have NTLM 0.12, which lives for 10 or 15 years, and you keep trying to throw in capabilities and functionality, and then 10 years later you look back, and it's just hard to recognize what a server can or can't do based on the dialect that it negotiates. So having clarity from a negotiate perspective that says, if I negotiate this dialect, these are the things that I'm aware of, and of that, I may choose to implement some or all of it, is what we desired. And then the other side is that we do have a limited number of capability bits as defined in the protocol. We have a lot of them left, but we want to leave room for future expansion. We don't just want to sort of use them aggressively, especially for relatively minor features and changes like we'll talk about today. The other thing that has come up more and more as we've done testing that we've realized as we write protocol docs and as we work through test cases that come from our protocol test team or are reported by you guys, is that some of the behaviors between the client and the server in cases where I see things that I don't recognize are inconsistent. So one of we're trying to offer much clearer direction moving forward to make both our documentation simpler, make our implementations more robust, and also make it simpler for other people to mimic our behavior when dealing with a client receiving capabilities that weren't defined at the time that it was implemented. An example of this is, what we'll talk about later, is in the tree connect response, there's a new bit which indicates an asymmetric share. Only a server who understands 3.02 should return that, but one of the questions that can come up through protocol testing would be, okay, a client who understands 3.02 who connected to a server that negotiated 3.0 but starts returning bits that he has no business knowing about, how should that client behave? And likewise, on the server side, if a client comes in and negotiates SMB2 but starts trying to use SMB3 features like multi-channel or CA or stuff like that, what should the server do? And most of these only come about in test-style environments. But it would be nice to have a little bit more just consistent rules so that we can kind of have the behavior be sensible in all these cases, as well as when we write the documentation, we can make it very simple to say what would happen. So from this point on, starting in 3.02, the guidelines that we're following is that a server that receives a request from a client that would include a flag or an option or a capability that was not valid, was not defined for the dialect that the client actually negotiated, should fail the request. And like I said before, if you read through some of the Windows behavior notes, I think, for our documentation, there were cases before where the server would implicitly say, well, if you're using either the multi-channel bit or something like that, we assume that you already know what you're talking about, but we didn't do the second check to say, did you negotiate 2.0 and try to use multi-channel? And the inversion of this from the client side, when I receive a response, here we have cases where you could have something like the REFS file system on Windows, which defined a new attribute, where a query directory is going to return that attribute that the client may not have been aware of. So on the client side, if you receive a flag, an option, or a capability that was not defined with a dialect that you implemented, you should ignore the flag as opposed to failing the request. Otherwise, we have a case where the server is going to have to basically take what comes back from the file system, try and look at what the client understands, and reparse everything. So these are kind of the guidelines from now on. And this offers a little bit more formal structure for how we define the protocols. It also is reinforced with this idea that we're going to introduce capability or introduce new dialects even for minor changes like we did with 3.02, just so that we have sort of a clear definition with, if you implemented this, here's what you were aware of, and here's how things should act. Yes?
I'm assuming the interaction, if you negotiate 3.02, still have the same expectations for capability as 3.0. So you don't have to implement all of 3.0.
Yeah, so the question is, you're assuming that like 3.02 would inherit all the same capability bits that were defined inside 3.0? Or is that?
I mean, the assumption is if a client negotiates 3.02, it's not stated that the server must have implemented all the capability bits of 3.0.
Yeah, okay, yeah. So the question is, if you negotiate 3.02, it's not implied that you have to have implemented all the capabilities of 3.0. And yes, that's correct. Now, what it does mean is, since you're implementing 3.02, you're aware of the capabilities the client's going to ask for. Like, you couldn't implement 3.02, but not even understand or comprehend multi-channel. You might choose to say you don't implement multi-channel, but at least it's defined and you understand it. And I mean, here's sort of a, I don't know if you, yes. Oh, sorry. I wrote this relatively quickly. The shoulds are interesting from, so the question is, with this slide, why are they shoulds and not musts? With respect to 3.02 features, we would define these as musts. I left them as shoulds because there is still this area of 3.0 and earlier where some server behaviors would match either what was documented, and I know that it wasn't as uniform in the past. So I guess you're right. Since I'm saying from this point on, we should put these as musts. So yeah, that's valid. So one of the things we can do now, this is an example for the write flags that can be issued on a write request. And in, I believe it was 3.0, actually it might have been 2.1, we introduced the idea of being able to flag an individual write as write-through. With 3.02, one of the requests is being able to tag flags as unbuffered. So we can define that here, and now we can actually have a very nice little array saying, okay, here's the valid flag mask for all SMB dialects, SMB2 dialects less than 3.0. Here's the 3.0 valid dialects, and here's the 3.02 valid dialects. And you can build these into a nice array. And now in your validate routine, when you receive a write request, you just AND it with your valid flags. And if anything is not there, or anything is there that is not defined in your valid flags, you can just fail the write request outright. So it lets us do pretty simple, pretty strict validation right up front that just says, is the client trying to use any capabilities that he should not be aware of? So it's just part of trying to formalize, what a dialect means and where the boundaries are. And for all you guys who write fancy test code that does all sorts of weird things, hopefully this means you find less issues. So, yes, Steve.
Thinking about the previous line, the example you chose was
Yep.
really good.
Yep.
So the example you chose earlier was really good about this REFS flag for integrity checking, right?
Right.
I hadn't forgotten, I didn't looked it up, right? So this was interesting, but the obvious question it prompts is, why is it REFS only? It looks like you set it for mirrored drives when you're formatting an REFS volume, but it actually brings up more questions that it answers. Why NTFS on a mirrored volume doesn't have integrity checking enabled, for example, and wondering sort of what's going on there.
So the question was with respect to the example on the previous slide where I think if we go back to, where we talked about the new file attribute integrity stream flag being present on REFS, and I think you're asking, like, why isn't it present on either NTFS volumes or mirrored spaces or other cases where integrity is available? I mean, this would be a great question. I don't know if Neil's stopping by, or basically the local file system team. From an REFS implementation, they're actually doing, checksumming on blobs and actually offering it as sort of an integrity level guarantee. And it is an optional thing that can be turned on or off per file. And I believe that's the intent of what this attribute means. But I'm not the expert in terms of when they set it and why they don't set it for NTFS or other things. I mean, from my understanding, NTFS doesn't actually allow this, guaranteed checksumming of user data blobs and stuff. But yeah, that would be a great one to pull up with the local file system guys, or get some of them out here if they just want to talk about what the meaning is of the new file attribute flag that is exposed through REFS, so that you can figure out in equivalent implementations when it would be appropriate to set it and not set it. So, cool. So I mean, so that's the general idea from a dialect perspective moving forward. So there's three main protocol changes, and the first one I want to touch on is instancing. And instancing most likely falls into the category of something you guys might be aware of, something you might end up deciding that you want to use internally for your own solutions, but honestly, in an interop perspective, it'll never come into play, and your implementation should be pretty simple. The main concept behind instancing, if you want to understand what drove it, is that if we look at what SMB3 has become, it actually provides very significant value just as a transport for other forms of data exchange outside of accessing files. Because we have a transport that supports authentication and authorization, we have encryption, we have signing, we support asynchronous I/O with interface discovery and multi-channel and RDMA, as well as if an app can sort of abstract its interactions behind a file system style API, you can actually just implement it across SMB3 without actually storing data inside blocks. So like one of the examples Klaus touched on is with Windows Server 2012 R2, we worked with the Hyper-V team to actually expose live migration over the SMB channel. So instead of using their own protocol where they go and establish TCP connections and do it, it's like, look, if you can expose migrating a VM as opening a file, writing it out, and closing it, then you can just run over us, and we'll discover interfaces. You get RDMA, you get all the perf work we've done, you get recoverability, you get a lot of the stuff that just saves you from implementing it. So SMB3 at this point offers such sort of a rich, wide feature set that there's more sort of solutions that we can, that at least internally within our own groups we see are interested in using it. The other example is cluster shared volumes. And cluster shared volumes, or as we refer to as CSV, Klaus touched a little bit on the architecture, and it's setting up a volume that appears as if it's available across all the different nodes, but might be hosted on one or more of the nodes depending on the storage backend. And it's using SMB3 inside the covers to actually redirect I/O around. And I'm sure you guys have other solutions or have read or thought about solutions that do various things. Part of the issue is with that solution in particular is as components take dependencies on SMB internally in your stack, there's reentrancy problems because we have a case where a client is connecting to a scale-out server to access a specific data. So he comes into the SMB server, which goes to our CSV architecture and decides that he needs to forward the request. So he actually hands it off to the reader, which now forwards it to the server on the peer node. And then you can also have a different client accessing a different resource, sort of coming into the other node doing the same thing. And these instances of essentially reader and server share common resources, whether it's locks or queues or look-aside lists or any of those things. So if you have the top-level consumer essentially get blocked for any reason, he can end up choking out the internal instance, as we would call it. And we can end up with deadlock possibilities, especially if you start looking at things like lease breaks or op block breaks. And I mean, we worked extremely hard so that we don't see these in production. But when we were looking into Blue, there's a much cleaner solution. And that's, what we want to do is keep one instance of the code, but basically say there's two versions of the SMB server running, where these versions have separate queues, they have separate locks, they have separate share tables, they have everything that's sort of separate so that as traffic arrives, we can basically fork it off into one or the other depending on sort of an architectural layer, if that makes sense. And This way, from servicing, again, we only have one code set to manage, but we don't have these reentrancy concerns because you can almost draw like a hierarchical model. So that's a complex way of saying a lot of stuff to give you some background on why we do it. From a protocol, the only change, if you read through, that comes in is there was a reserve bit in the negotiate that was a must be 0. And now, essentially, that is an instance ID that can be anywhere between 0 and 255. And when it arrives, if it's set to 1, we look and see if there's a server instance with ID 1 running, and we hand the connection off to that guy. Whereas if it's 0, it goes to what was the default and top-level instance. So for interop perspective, there's no use of instancing outside of our own internal cluster communications. Like, there's no reason I think we need to be discussing across. And in fact, you should never actually see a negotiate come out with an instance ID not equal to 0, because our client wouldn't be connecting out with it. So essentially, this shouldn't affect any of your own implementations. But it does give you the ability, if you're in a similar situation, to say, I need to have SMB traffic flowing between my servers for my specific solution, but I want to segment that off from sort of my public-facing SMB traffic. Here's how you can sort of create your own sub-instance. So, yes. So here's the only protocol change associated with instancing is what used to be a U-short reserve now contains an instance ID. So
is the intent for this, I mean, truly just to be internal? I mean, this seems to be like a prime candidate to replace server consolidation in multi-tenancy, where essentially you just bind a multi-home config. I mean, this seems to be, is there maybe this is more of a product question. I mean, this seems to be usable way beyond just internal use. Is this, I mean, it seems like you could bind this to a multi-homed host and actually have a sort of demultiplex staging area that binds to multi-tenant SMB servers.
I mean, from my perspective, it is purely for internal use, simply because from a client perspective, like on a server, it does offer the, the multi-tenant guarantees. But from a client implementation, when you go through UNC name resolution, the question is how you would determine based on the name what instance ID. Now, you could, we'd have to have top-level application changes. I mean, there are possibilities there. And it's generally designed to be a flexible mechanism that says you could run as many instances as you want.
Fair enough.
So yeah, I don't know what the future will hold. But we'd have to resolve the client side. I mean, it could be like I don't know, virtual network stuff or something like that too. So for read-writes, there were essentially two small changes that come in for the read-write packet. One of which is adding a flag to allow unbuffered I/O on individual I/Os, and then the second one, which I think Tom talked about yesterday, was support for the RDMA remote invalidation feature, which is more about performance improvements. So with Windows 8, we added this flag that allowed you to tag individual writes as write-through. So in this way, an application could open up a handle to the file system with the normal modes and actually tag individual writes, saying this one I want write-through semantics, whereas these other ones I want normal cache semantics or whatever. The NTIO model internally on the client allows you to tag individual write requests as well as unbuffered, requesting that you basically would not buffer this at the file system or at the disk cache level. And really what this was is just extending the individual write flags to allow you to tag an individual read or an individual write as saying, please don't buffer this write. Please send it all the way to the storage stack. And on receipts, server would have to do the same I/O alignment requirements that you would if they had opened the handles unbuffered, where you need to make sure the offset and the lengths are sector sized, and then just pass this flag down to the storage system. So this is the one, in terms of doing 3.02, this is the one change that most people would probably need to do to claim support. The other ones are all optional. But odds are you already have all the code in your system to do this if you support the file flag no intermediate buffering. It's just that now you're basically enforcing it per I/O instead of just being able to look at the top-level file handle and decide if you need to enforce it. This is used primarily by Hyper-V and with VHD opens when they have cases where they want to do unbuffered I/O and stuff. So here's the flags. There's one both for read and one both for write. And yeah, when you're set and validate, you just need to, if this flag is set, you need to do the same validation as if the file was open unbuffered. And then you need to pass the flag down to whatever your disk subsystem is to ask it not to do buffering. So remote invalidation. I think Tom talked through this some, and I can talk through the things as well. These were stolen from Tom and Greg's SDC presentation from last year, if they look familiar. So if we look at how, I believe this is a read, yeah, a read over RDMA works currently, is when the app issues the read, the client is actually going to have to register the actual application buffer with the hardware and then send the request to the server. And then we'll get completions from those individual operations. And then the server will actually write the data that was being read from the file system back to the buffer, send the response, which will go back to the client. And at this point, we need to deregister the application buffer to ensure that it's not available for anyone to operate on. So we have to go back to the hardware here to unregister it before we complete the I/O to the app. Because by the time we complete the I/O to the app, we want to guarantee that no further changes are going to come unexpectedly to their buffer, its security boundaries. And this range right here basically means we're going to consume more CPU. We're going to have to go back to the hardware a third time, and thus we increase latency, and it was an opportunity to increase performance. And the RDMA protocol, or verbs, I guess, drivers, whatever, give us the option to do something called send with invalidate, where when the server sends the response, he can actually indicate to the hardware on the receiving side, go ahead and invalidate the buffer as part of that, which allows us to skip that third round trip to the hardware and basically just complete back up to user mode. So this is part of sort of the optimizations to increase our IOPS numbers, especially for small to medium IOs and things like that. So if you have questions about the RDMA specifics or the SMB Direct protocol, Greg is right there. Tom's on the phone. Those would be the best guys to talk to about this in depth. So in terms of SMB2 or SMB3 changes, there was a channel information field which was present in a read or write request, which was used to identify if this was using the RDMA channel, which is this channel RDMA v1. And now we have another definition which says this is an RDMA v1 with send and invalidate. So if we use 3.02, the client can set this flag if he's requesting the server to do it. And you can see that we updated the maximum capability. So again, if you don't implement RDMA, this isn't necessary. I believe from an RDMA perspective, even if you do 3.02, if you don't support it or the hardware doesn't, then at the SMB Direct protocol layer, you can indicate that you didn't do send with invalidate, and the client will fall back to the 3.0 behavior and do the invalidation anyway. So this is another part of the SMB3 protocol that is, or 3.02, that is optional. Again, very few changes here, or almost no changes that I think are really significant work that are required. So the last one I want to talk about is the asymmetric shares, which goes along with the server load balancing that Klaus talked about previously. So just to make sure we're all on the same with terminology, this was the picture of what we call a traditional clustered file server, where there's a single instance of the server. It lives on one server node, and if a failure occurs, this instance might move to another server that's waiting in standby. So this is an active-passive configuration. And when the client connects, he'll always connect to the node that's hosting the resource. For Server 2012 and SMB3, we move towards active-active modes in what we call a scale-out server. And in this case, the client can connect to any of a variety of nodes. DNS lists all the nodes, and all the file servers share out the resource. So it doesn't matter which one I arrive at, I can actually get to the resource. The SMB3 clients, at least from the Windows implementation, will only connect to a single server at any given time. And all the data is shared, although you can have some volatile states, such as the file IDs and session IDs, which are local, but we support failover between the nodes if failures occur. What asymmetric shares are focusing on is that you could have modes or operating modes that are like this, where for a given share, the client has arrived at the middle node, but from the way we implement our storage stack, for this particular share, we're going to actually have to forward data requests, some portion of them or perhaps all of them, to a peer node to actually get to the storage. So when we're in this mode, we're sort of stuck in a non-optimal mode, where the client is talking to a node where there's a higher cost to access the data than if we could just get the client to talk to the node on the bottom. So all asymmetric shares is really about is if we know these configurations exist where access to storage is unbalanced and there's a benefit to being on a specific node, how can we go about getting the client to connect to the node where data access is optimal? So with an asymmetric share, when the client negotiates 3.02 and does a tree connect, in the tree connect response, there's a new capability that can be returned up for the share that says this is an asymmetric share. It's a hint to the client that says, look, you're free to access data through me. It'll work perfectly fine. But you could probably be faster if you go to a specific node. And if you want to ask me about where to go, you can go ahead and do it. This was meant to be iterative to build on the witness protocol, as was introduced in SMB 3.02. So a client can now choose to register with witness to get a notification with where to move to get sort of the optimal data path. And then at that point, we go through the same behavior as if we had received a move client request, where when witness tells us, hey, you really should be on node 3, here's the IP address, we'll disconnect, we'll reconnect to node 3, we'll build up a multi-channel pool to node 3, and we'll rebind all our file handles, and we'll keep working. And using witness is interesting, both that it gives us that initial redirect. When we first connect, it'll tell us where to go. But also, if situations change in the cluster and storage moves around or disks move around or load moves around, I can get requests later that basically say, hey, I know I told you to work on node 3, but now I really think you want to be on node 1 for this share. And I can send a message to the client, and he'll actually move to node 1. Another point that I want to call out, sorry about that. I want to call out here is when we introduced SMB3 with scale out, the sort of the golden rule at the time was to say that the Windows 8 or Server 2012 clients will only connect to an individual server in that cluster at any given time. So all shares, we would connect to that one cluster node. With asymmetric shares, the client will be building up a connection pool per share, essentially, which would allow you to move those around. So if I have 100 shares, those could be distributed across all 8 of my nodes, and those could move around dynamically, and the client will follow them. The one other thing to note from that, though, is you do have a full multi-channel connection pool per share. So if you try to scale this to 10,000 shares, you're going to have a whole lot of connections, right? If you multiply by 100 or 10,000 clients. So deciding, if asymmetric matches your use case, those are things you definitely want to keep in mind. Yeah, so this is calling it out. The client will now talk to multiple servers for different shares. The other thing I want to say is, we sort of view having the app not experience failures as being paramount over performance, which means if you've asked the client to go to node 2, but we receive some sort of failure or disconnect, can't authenticate, or something like that, we will go back to choosing any of the available nodes that work instead of just basically staying on node 2 and then failing the application request. And the move SMB witness PowerShell command won't work for clients connected to an asymmetric share, because he's already getting witness notifications asking him to go to a specific node, whereas the move command is more about asking a client to move to a specific node. So this commandlet specifically is not compatible with share level registrations. So one question that can come up is, why did we do this per share instead of per file or per directory or anything else like this, right? Like, why aren't we doing a redirection at a lower level? And realistically, given the short cycle and the fact that we're trying to iteratively build on the witness here, this was more about a simplicity choice for this turn of the crank. And it also matches, at least within Server 2012, a lot of the load balancing is disk or volume or sort of pool level load balancing. So while you could build in the capability to do this at the file level, normally what's getting moved around between nodes within our architecture is larger scopes, which are volumes which contain entire shares. So it's not to say that this is the best or the final solution, but this is, I think, a step in the right direction and things like that. And asymmetric shares are probably the biggest of the features that we're going to sort of talk about in 3.02. And again, they're optional in the sense that if it matches your architecture and if you see there's benefit in doing it, it's something you can pursue. It's also something you can pursue sort of as an add-on later on. If you're not doing scale out, or if your file system doesn't have these properties where one node is essentially faster to access than the other, you might actually find that they're really of no benefit or no use for your individual scenario. So I'm just sort of wrapping it up and reinforcing this message that with 3.02, this isn't anything to be concerned about if you're almost done with 3.0. Most of it is either iterative or minor or perhaps even scenario specific. So. Just an implementation note, if you want to test this with Windows Server 2012 R2, by default, we only mark shares as asymmetric if they're using mirrored spaces configurations underneath. Because for a SAN or an iSCSI deployment where we're not using mirrored spaces, multiple nodes can access the data directly, so there's benefit in keeping the client sort of fanned out across multiple servers. If you want to test it, but you don't want to set up storage spaces, pools, and a cluster configuration, I threw a little reg key on the bottom where you can mark all the nodes to say, hey, treat all scale-out shares as asymmetric. And then you can actually see this behavior. But that's purely our implementation. Yeah. So we can talk a little bit. I'll go through some of the witness changes here, too, while we're here. The other note is if you run get SMB witness client PowerShell commandlets, you can actually see if a client's registered using a share level registration by if the share parameter is basically non-empty. If it's empty, that means client's doing server level registrations. On the client side, there's actually, if you run get SMB connection, there's also a Boolean called redirected, which says whether from the client's perspective, he thinks he's operating in asymmetric mode or not. So does anyone have questions about asymmetric shares? That's really sort of the biggest change here and stuff. Cool. If not, like I said, feel free to find me later and we can talk further. So for witness specifically, there's a new method for witness registration, which is the witness register EX, which adds the three things that I note there. We support share name field now because we want to be able to do share level registrations. And we also have a flags field where you can indicate what registration mode you're using. Net name registrations and share notifications are mutually exclusive. You're either doing one or the other. Because for a share, then you essentially have both the net name and the share name that are valid. For a net name, then the net name is valid and the share name is ignored. The third one that was actually added is multi-channel notification. So what multi-channel notification is really doing is it's giving the client insight into addition or removal of network interfaces as IPs are added to the system or removed from the system. With our implementation, a Windows client doing a share level registration will also ask for multi-channel notifications. And if we get IP offlines, then we'll essentially try to accelerate disconnecting and canceling out connections. The one thing that isn't tied in on the client but could be is, the server will send notifications when interfaces arrive, which would give us this ability, the great demo where now you can, light up or you plug in a network interface on the server and the client gets a notification right away and fires up multi-channel and spreads across to it. That side actually isn't implemented in Server 2012 R2 as of yet, but the intent would be to eventually add that in. Right now, you'd still, if you plug a NIC in on the client side, it'll light up right away. But if you plug it in on the server side, it'll get picked up every 10 minutes when we do our normal polling to see if any of the interface configuration stuff has changed. So, yes, Steve?
So the clients today do query network interface FSCTL every 10 minutes?
Yeah, so the question is, for multi-channel, do the clients do the query network interface FSCTL every 10 minutes? Yes, the clients will essentially run that every 10 minutes. They'll also run it if their local network interface information changes, like if you add or remove a NIC locally, and they'll also run it if you run the update SMB multi-channel connection PowerShell commandlet. So you can force it anytime through PowerShell.
So that PowerShell command was?
It should be update-SMB multi-channel connection.
Okay.
So
yesterday I was looking at this query network interface quite a bit, and the obvious question is, it returns not just the list of interfaces, but I mean, you noted your context here was multi-channel. I think there's information in there, the capacity, for example, possibly other things that are useful to query independent of whether you're trying to do multi-channel or RDMA. Do you know, in the stuff you get back from that PowerShell commandlet or you get back from the query network interfaces, what might be particularly useful to the client to know about, other than, okay, this is the list of interfaces?
So from our client execution, if multi-channel is disabled or if we're choosing not to go multi-channel, then we're only going to operate on the IP that we resolved from DNS. So the additional attributes right now shouldn't have any effect on how the client processes. Now, we will go multi-channel in situations that aren't traditional multi-channel cases. Like if the server has two interfaces and we realize one's faster, the client, even with one NIC, might choose to hop over to a different one. Or the classic case is the laptop with both a wireless and then when you plug in wired, that's actually a multi-channel situation where we'll say, wait a minute, new interface arrived, is there optimal paths? But in general, in absence of multi-channel, I don't even think the query will go out if multi-channel hasn't been enabled on the client. So,
I mean, what I was saying was that without multi-channel,
Yep.
you're always going to return, I mean, by
Yep.
default, to IPv4 and IPv6. Because you're going to expose both those and you return both those. So it's kind of useful to know your IPv6 address because you probably connected on IPv4 or whatever.
Right.
But the laptop example I thought you chose was a pretty good one. But you also get the RSS, whatever, I forget what
yeah, like the RSS capability, the RDMA capability.
and I forget what RSS capability is.
That's the receive side scaling. So that's used mostly to determine if setting up multiple connections will scale across multiple CPUs on the server side or the client side. Like,
So that's specific to multi-channel, not something we care about on multi-channel.
well, that's specific. That's a NIC implementation. Multi-channel cares about RSS because when RSS is enabled, that says even if you have a single NIC, there might be benefits in me doing multiple connections on that NIC. So 10 gig is the classic example where if I have a single connection and I'm doing small I/O, if it's a non-RSS adapter, all those interrupts are being handled by a single CPU. So the benefit of me doing multiple connections, even though I can't saturate 10 gig with small I/O with a single connection, is low. But if the RSS bit is true, and then essentially the client can set up, I think we default to 4 connections. And now, as I issue the small I/Os, the interrupts will be spread, ideally across 4 CPUs on the server side.
Because
So that might be the case you're asking where multi-channel matters, even though there's only one network card on both sides.
Yeah.
So.
Because I mean that would be a great one because if I can, because I mean I have mount option today for that to force a second connection
Yep.
from the same client to the same server, and then finally you have the capacity estimate number. And I was wondering if you can think of any case where we care, like if the server reports more or less capacity than we think we are on our adapter.
Right. Yeah, the interesting from a multi-channel side is the bandwidth usage field ends up being not as useful as you'd like, specifically because of virtualization. And that's from a Hyper-V scenario, all virtual NICs report that they're 10 gig, even if they're physically backed by a 1 gig network and stuff. So relying on bandwidth, the main thing the client uses the bandwidth number for is if I have to choose from a selection of interfaces, at that point I'm going to choose the one that the server claims has the highest bandwidth. But in terms of determining if I'm going to do multiple connections or only a single connection, that's based on either the RDMA or the RSS flag. From your side, if you want to force multiple connections from the server side or from the client side, then yeah, if you set the RSS property to be true. What we've seen though is that like for 1 gig we can saturate easily, with a single connection, and then for 10 gig is where we need multiple. But again, if you're not actually diverting the interrupts across multiple cores, you're likely to end up CPU bound before you can fill the bandwidth anyway.
Set up 4 connections when RSS is
Steve,
enabled.
we had a recent issue in the doc about clarifying some of the RSS and multi-channel behavior. And there is a small amount of new text in there. May not be in the preview yet. But RSS is very important and it's supported by most NICs, therefore by most operating systems. And I'm sure you have analogs in the platforms you port to.
And just to confirm what you just said,
It would be,
when the RSS flag is on, we're going to, the Microsoft, well, some Microsoft
The Windows client will connect multiple times only when RSS or RDMA is set.
yeah,
If RSS is set and you have 1 NIC basically,
you would do 4 connections.
you do 4
across
connections to that.
If RSS is both on the client and the server side.
Yeah, the server has to report RSS and the client has to have some sort of ability to do it as well.
Yep.
Okay, well that's
So
useful.
there's
That's
a
useful
local
info
between-
because it's common to have one adapter with RSS and Windows behavior starting in something.
SMB3, so Windows 8 is where multi-channel came. And actually, you can run, there's another PowerShell commandlet that's useful if you're trying to diagnose it, which is get SMB client network interface, which will actually display from the client's perspective, here's the properties of the network interfaces SMB is bound to. And that should include information like, do I think my adapters are RDMA or RSS capable? And there's actually a bunch of PowerShells. I think if you go to Jose's blog, I don't know, I think that's smb3.info. He has a whole bunch of them. There's a bunch of SMB or multi-channel related PowerShell commandlets where on the client you can really view what does he think the server has, what does he think the client has, and what's his decision matrix where he's decided where to put his connections and have they succeeded or failed. So it's really easy to diagnose when you have it up and running. And I can show you those too. So.
And Steve, don't be afraid to innovate here. The Windows decisions are certainly there as a start, but it's a really subtle area. and balancing the traffic and getting the number of connections right. It gets especially interesting when the client and server have a different number of NICs.
Yeah.
Right? You may want to create multiple connections when it's a one-to-many, but there are other reasons why you may not. So they play against each other sometimes. You have to think it through.
Cool. So one of the other fields, if we go back to the new Witness Register EX interface, there's one called the Keep Alive Timeout in Seconds. And what this was addressing is that basically RPC over TCP timeouts, in the case where either the client or the server disappears, are very coarse. And sometimes, even if you're asking, RPC to set its min timeout to 0 from the Windows implementation, that could mean, well, I'm going to do keep alives every 2 to 3 hours. So now you have a client who has a witness registration, that node crashes, and the client doesn't realize that that node is gone for multiple hours. So he's sitting in a situation where he feels like he has this benefit of getting notifications of servers crashing or going down, but really he's not. So optionally now with the Register EX, the client can actually provide a keep alive timeout in seconds. And the only semantic change here is on the server, if I have a pending async notification call that waits for longer than the client specified keep alive timeout, I'll go ahead and I'll complete it with error timeout. That works as, the client gets that, so he says, okay, I know the server's still alive, and now I'll basically repost the notification back to it. So there's going to be some chatter every keep alive timeout. But this also lets the client use the call timeout property of RPC to say, look, since I know this call has to complete within the keep alive timeout, I can tell RPC to fail it if it doesn't complete in the keep alive timeout plus some interval. We use 60 seconds. So by default on the Windows client, now when we register, we set keep alive timeout to be 2 minutes. And if we don't hear anything back from the server in 3 minutes, we set up RPC to fail for us. So we're guaranteed now that both client and server will discover basically that the other one has gone away within a matter of minutes instead of potentially a matter of hours. And we do pay something in respect to bandwidth and chattiness, but in CA scenarios where we're using Witness, we think getting these exchanges every 2 to 3 minutes is worthwhile. And this is the reason where if you start working with a Server 2012 R2 client, you'll notice that he's going to attempt to do the Witness Register EX even if he's doing net name level registration. And that's because he wants this keep alive timeout behavior. And only if that fails will we fall back to the original Witness Register, which is, as of Server 2012, which doesn't have this functionality. So I wanted to touch a little bit on the diagnosability thing. And Klaus called it out, but I just sort of want to reinforce it that a lot of the efforts here are trying to do some persistent always-on logging of when events occur that are relevant in SMB and CA style scenarios. And as server or client implementers, there's a lot of useful information here that you guys probably will find helpful, especially as you start implementing things and testing things like CA. So for example, if you go to the event viewer and open up the application and services logs, go to Microsoft Windows SMB client, you'll basically see 3 channels now. There's an operational channel, a connectivity channel, and a security channel. And we'll actually log events, relatively verbose events, for all sorts of really interesting scenarios, like when connectivity, when we attempt to connect and it succeeds or it fails. For one of the big ones is like if we have a persistent or a resilient handle that we couldn't reestablish, we'll log an event with information saying, hey, look, this handle failed, and here's a bunch of information about it. So if you have like a Hyper-V machine running and a VM crashes using Hyper-V over SMB, you can actually go to the SMB client log on the Hyper-V node and say, okay, from the SMB level, did we see a handle failure? And show me some information about it. We'll also talk about if there's signing or encryption or negotiate failures. And we'll log when Witness delivers notifications asking us to move and do all sorts of things. And there's also the Microsoft Windows SMB Witness client. So I mean, I just pulled this example from a mail exchange from a couple days ago. If you want to walk through it. So this is a failure to reconnect a persistent handle event. And the actual error that was passed up is that the status connection disconnected. And this actually shows you the file ID of the file that was attempted to be reconnected. It shows you the create GUID, and it shows you the path, including the name. So this was actually a Mayhew open to a shared VHD. And then it gives you, from the client's perspective, the reason why this thing failed. And in this case, the reason was the connection object was suspended by the client. But it also shows you the previous reason. So the time before, so this was what happened the last time we tried to connect the handle. The second to last time we tried to connect the handle, we actually had a disconnect transport which again was related to connection object was being suspended. And then we'll have this long guidance text, which is more for admins and stuff reading this to give them some insight into what they may or may not want to do. So this is the format that's sort of followed for all the client events. In this case, connections are suspended when we get witness offline notifications. So when the witness asks us to move. So using this, we could go back through the witness message delivery events as well as the sort of connect events, and we could see that what happened is the client received a disconnect originally. He went to connect to a node, and then he got a notification from witness asking him to move to a different node. So he suspended his connection. He reconnected to the new node, and he was in the process of reestablishing all his handles when he got another witness notification asking him to move back to a different node. So now he suspended it again, and he was trying to go over there, and there were just a handful of handles that basically didn't make the timeout window because he got moved too many times. But the cool thing is we could actually see this all post-fact. Like we could just pull the event logs and read it as opposed to having to gather sniffs and traces and dive in. And what I'm just trying to say is you can see this information too. It's all printed out in very clear text. So I think you guys are going to find, like, you know, if you start seeing issues with signing or encryption or just disconnects and you don't know what it is, start popping this up and seeing what works and what doesn't. And then from our side, as we run through more and more cases where we can't discover what happened, especially on a customer site, we want to continue improving this and making it useful. So feel free to send us feedback and do other things. For those of you implementing clients, the same thing goes for the server, where there's the Microsoft Windows SMB server, where you can see the same level of information on either, you know, signing or encryption or authentication failures. We log things when you attempt to use anonymous access and it's disabled. We tried to basically go through our support database and say, what are all the things that customers are hitting that's problematic for them and then costs everyone money to try and trace down what's happening, and let's make it really simple just to throw up into the event log and pop up as errors or warnings. So yeah, definitely use clients and servers, take a look through those, see where they're useful, see where they're not, and let us know how it works. Yes? So the question is, can we elaborate on what a SOAP file system operation warning is on the server side? One of the common things that we end up debugging is either we see a client-side timeout because operations don't complete in 60 seconds, or we have a customer say, hey, you know, I'm accessing my file server and it just feels slow. And us as the SMB team, you know, it comes to us to say, okay, try and figure out what this is. And a lot of times what it is the underlying disk system is slow or fast. And if we could just at least figure out, is this an SMB problem or is this a local file system problem, it's helpful. What we do now on our server is if you're running a workload and if we have a non-asynchronous operation that blocks in the file system for more than 15 seconds, or an SMB async operation that blocks in the file system for more than 2 minutes, not counting change notifies or blocking locks or things that are expected to be infinite, we'll log an event that says, look, I just issued a write on this file, and I expected it to take under 15 seconds, and it took 35 seconds. And then if these accumulate, it at least gives us evidence where now, okay, if the customer starts seeing SMB level timeouts, we can come back and say, well, we need to look at the storage system on this guy because for some reason your writes aren't completing for over 30 seconds, which is definitely unexpected. So, yes? So the question is there a document where we can look up the warnings? I don't know if there's a formal document yet. They are, I need to figure out, because they're published in the manifest, so they ship as part of the operating system. But I need to figure out if there's a good way to actually just output everything, like all the various events that come through. I can talk to Ned, who was here earlier, was actually the PM for it, and see if there's a way that we can actually export the manifest into a human-readable format so that you can read through. So I think Ned said he was going to be back at 4:30 today, and I can give him a heads up, and we can try and get that for you. So, and I mean, obviously this is very Microsoft Windows Event Viewer specific, but as an ecosystem, I think if we can all sort of understand, what's useful for customers to debug, and they're, as we're all interacting with each other, and make an effort towards, I don't know how logging looks on the various implementations, but I'd love to see the point where we can at least get client and server logs and view both of our views of the world and figure out where we need to dive in when customers start having some of these issues. And especially as we move more into enterprise level, scenarios, the whole goal is if a failure occurs once, we want to have actionable information. We don't want to go back to the customer and say, well, gee, I'm sorry, your system went down, but can you turn on this tracing and let your business crash one more time for me? We want every failure to be actionable in some sense. So, and that's all I have. So at this point, if you guys have questions on any of this stuff or anything else, feel free to ask. So, yes.
So you talked about the file system can be local to a node. Can I create a CSV on top of that?
You mean, can I create a CSV on a local file system?
When file system is local to single node, not accessible from the other.
Yeah, that would be more of a question for the clustering team, and I'm not sure how much they expose. To us, we treat CSV as a clustered file system, and then they can expose attributes that say whether there's benefits to be on a given disk or not. So that'd be more a question for the CSV team. So. Cool.
Others?
Yeah. If not, I'll be around for a little bit if anyone wants to ask anything.
Great. Thank you very much, David. Appreciate it.